Hello friends, this is Bright here. In this video, I am going to explain about socket programming. So let us know what is this socket. The simple definition goes like this. Sockets are endpoints in a connection. Imagine that we have two systems, system 1 and system 2. If we want to transfer from system 1 to system 2, we need a connection in between. So the endpoints of this connection, we call them as sockets. So in simple manner, we can say that socket is an interface. And there are two types of protocols in socket programming. The first one is TCP. In this video, we are going to see about TCP-Socket Programming. The other one is UDP. So where we can apply TCP and where we can use UDP. Let us see a simple example. Imagine that we are watching a live stream of video. So there in between we feel that the video is frozen or getting stuck and little bit of data will be lost. Then again we are comfortable in continuing watching. That is done with the help of UDP. UDP in the sense whenever there is data, the data can be sent. But in the case of TCP, it is not like that. If we want to transfer the data, we have to establish the connection. Only after that we can transfer the data. In the case of UDP, there will be data loss. So in the case of live streaming, the data loss will not be that much trouble for watching. But in the case of TCP, imagine that we want to send a file. I want to send a report. Let us say the report consists of 5 pages. And in the receiving side, if I am not getting 2 or 3 pages of the report due to data packet loss, it is not acceptable. So in the case of TCP, we can ensure that there is no loss of data. Data packets will not be lost. But in the case of UDP, there may be little data loss. So TCP can be used for sending some confidential data where data is very sensitive. In the case of UDP, live streaming data, in such cases where the data loss is not a big matter. Now, as I told you that TCP is a connection oriented protocol, we have to establish the connection, only then we can transfer the data. For that, we can take a simple example about telephonic conversation. So if I want to communicate with a person through telephone, first I have to dial a number. So I am sending a connection request. The moment other person picks up the telephone, who is in the other end, the connection will be established. Then we can communicate over. The same case about TCP. So first in our programming, we are going to send a connection request. Once the connection is accepted, the data can be sent or the data can be transferred. Now we are going to see how it can be implemented in Python. So I am using PyCharm. Here I have two Python files. One is sam.py and other one is sam2.py. And since it is of data transfer between two systems, you can keep the sam.py in one system and sam2.py for other system. For the recording purpose, I am keeping both files in the same system. So let us say sam is for system 1, sam2 for system 2. For socket programming in Python, we have to import a module called socket. After importing, the first step is we have to create a socket object. For that, I am going to name for that object as s equal to module name dot class name with set of parentheses. So the second socket, it is for class name. If you are working with the Windows operating system, press Ctrl. We can see a link is coming, click it. You can see socket.py, where socket is a predefined class. If you are working with Mac, you can see, try with command and click it. So depends on the system we are using it. So remember, this first part socket is the module, the second one class name. So we created a socket. Then next step is we have to associate our socket object with a port number, where port number ranges from 0 to 65,535, and we should know what is the purpose of port number. In a simple manner, we can say that it is used to identify a particular service. There are different kinds of services. For example, you want to access a web page, google.com. At that time, it uses a protocol called HTTP, Hypertext Transfer Protocol. It uses a port number 80. Now there is another protocol called FTP, File Transfer Protocol. It uses a port number 21. Then like that, there are so many services are available. And now for our service, we are going to use a port number within this range. But remember one more thing, from 0 to 1023, these port numbers are already associated with various services. Already associated with various services. So it is better to use from 1024 to 65,535, and the 0 to 1023 we call them as well-known ports. We call it as well-known port numbers. Imagine that we are taking 80, but it is already associated with HTTP, and there is a probability of conflict. To avoid that, better take a number from 1024 to 65,535. So I am going to use a port number 2000. To do this operation, use the socket object and call the method bind. Then the argument to the bind must be a tuple object, where the first argument is the IP address of my system, or we can say that it is the localhost. To represent the localhost IP address, we can type 127.0.0.1, and the second argument to which number we want to associate. Let us say that 2000. So the purpose of binding, we should understand, to reserve a port number for our service. After this, we have to keep our system, let us say system 1, in listening mode. This is very important. As I told you earlier that if I want to talk with another phone, as I have already mentioned that if I want to communicate with another person through telephone, the other person's telephone must be in the listening mode. The same thing, if any other system want to send a connection request, my system should be in the listening mode. For that, s dot, a very simple method is there, listen. And now I am going to write a while loop with always true, means infinite while loop. Here my system will be waiting for connection request. Wait for connection request. For that, we can use the socket object dot accept. So when this line is executed, here it will be blocked, or it will be waiting for input connection request from other system. So as soon as a connection request comes, this accept method will be executed and it returns a pair of values, value 1 and value 2. Let us say v1 and v2. So this accept method returns a pair of values, value 1 and value 2. And value 1 is our new socket object, where through this new socket object only we are going to do the data transfer. And the value 2, it represents the address of the system which sent the connection request, that is address of system 2 which send the connection request to system 1. So let us give some meaningful name. We can say that my socket. Second one, address of other system. Address of other system. And we can give a display like this. Print, we can say that connection accepted from now this address of system we are going to put it, but we should know one thing, this is a tuple object which contains address of the system as well as from which port number it has come. So we need to convert that into str. I'll explain this part little later when we are running the code. So connection accepted from that other system. And now we are going to send a welcome message to the next system. Let us say that system 2. For that, spelling mistake, SOC. Now using this socket object, that is my socket object, we can send the data. I am using the first method, send welcome. But there is a small problem here. Welcome is an str. Send method can send only bytes. So we have to convert this into bytes. Do the typecast to bytes. And when we are converting from str to bytes, we have to specify what kind of encoding we are using it. There are different kinds of encoding. UTF-8 encoding, ASCII encoding. I am going to use UTF-8. Its full form is like this: 8 bits Unicode transformation format. So it will send the data. As soon as the data is sent, we are going to close our my socket. That is, close the connection. We can say that my socket dot close. So closing the socket. Again, while loop continues, it waits for another connection. It may be from the system 2 or system 3, any other system. Now we are going to code for system2, that is for sam2.py. So here also first import the module, import socket, same steps will be followed, create socket object, let us say that s equal to module name dot class name with set of parentheses, it creates a socket object, then bind our socket to a port number. For that we can use s.bind. It takes an argument which is a tuple object. The first argument IP address of system2. So here, since both system1 that is sam.py and system2 sam2.py are running in the same machine, I am using localhost IP address. If you are trying from a different machine, take the IP address of that system and places it. If you are trying from another machine, take the IP address of that system and place it in the place of this localhost IP address, followed by to which port number we want to associate. So now the system2's IP address, and in that system2 which port number we are reserving. Now we can send a connection request to say system1. For sending a connection request, s dot connect. Now this connect method requires a tuple object. The first argument in the tuple, the IP address of our machine 127.0.0.1. So if you are trying with a different system, you have to pass the IP address of system1 here, followed by system1 is using a port number 2000. So system1 is listening through the port number 2000. So that is the next argument. So it sends a connection to this IP address where that system is listening through this port number. So these two parameters are mandatory. These two arguments must be packed in a tuple object and pass it as an argument to connect. So when this line is executed, a connection request will be sent to system2. So when this line is executed, a connection request will be sent to system1. Then here, this is the place system1 is waiting for connection request. It will accept the connection. It will give a status like this: connection accepted from address. Then this line will be executed, sent. When this line is executed, the welcome will be converted into bytes by using the encoding UTF-8, and the data is sent. And that data arrives at SAM2 and we can receive it. Receive the incoming data. For that, s dot, there is a very simple method, recv. And here we have to pass one input argument, that is our buffer size, input buffer size. Let us say that 1024. It means 1024 bytes it can receive. That is the maximum input buffer size. according to this code. Or if we want, we can say 100. Then at a time it can receive maximum 100 bytes. So let us store the data in a variable called message. The next step is we have to decode the message and print it. For that, for printing, we can use print. To decode the message dot, there is a function called decode, and there which encoding we are using. We can see here we are using 8-bit Unicode transformation format. So we have to use the same encoding format. So after receiving it, we can close it. Close the socket. Take the socket object dot close. Now first we have to run sam.py or system1, because this is the place it is listening and waiting for input connection request. So let me run it first. Run sam. Oh, this 2000 is not free, so you can see address already in use. Let me use a different port number. Let us say 2500. Now when we change the port number here, we should be very careful in system 2. When we are sending a connection request, we are sending two arguments here in a tuple object, the IP address of that machine, that is system1, then followed by through which port number it is listening. So I am going to put, since there we changed that it is 2500, here also 2500. Yes. Now let us run it again. Run system1. We can see that it is now in running mode, it is listening. And sam2.py, run it. Run sam2. We can see in sam2 we got the message welcome. In SAM, you can see that connection accepted from. Let me explain what is that address. Connection accepted from, here, address of other system. So that is one of the variables mentioned here. You can see that when accept method is executed, it returns a pair of values. The first value, a new socket object, through that we can do the data transfer, whether it can be sent or received. And address of other system, it contains a tuple object which has two arguments, the IP address of the system which sent the connection request and which port number it is using for its service. We can see that here we are using 3000. Actually this line is an optional line. If we don't put s.bind method, so imagine that we are not using it. Command slash. Now I am going to run this again. We can see that the system1 is already in the running mode. Now I am going to run sam2. Run sam2. Again we are getting the expected welcome is sent from system1. Now look at sam. See, now it is taking a different value, 60,989. It means that in sam2.py, that is, if we don't write the bind method, the system will automatically associate a free port number for our socket. Here also the same thing. In system1 sam.py, if we don't bind it, it doesn't give any trouble for us, but automatically the port number will be allocated. And now here when we are executing the connect method, we have to get that port number. We should understand which port number it is listening through. That port number we have to put it. So now here system 1 is sending the data and system 2 is receiving it. Now let us see the data transfer from both sides. Now after the connect method, here we are going to send the data. Send data to system 1. For that, very simple method, s dot send, we can say that from system 1 good day. But again we need to convert this into bytes. While converting, you have to mention the format. I am going to continue with UTF-8. So now when this method is executed, a connection request will be sent to system 1. So accept method will be executed, and here we are sending a data welcome, and that is received by SAM2. So after accepting, I am going to receive data from system 2. Even we can try after send method also anytime. So here my socket dot receive, we can mention, for example, I am going to put the input buffer is 100. We can store it in a message variable and print it. Print message dot decode it by using UTF-8. So now let us run again. So first again we have to run sam.py, run sam. We can see that now it is in the listening mode. sam2.py, run sam2. You can see that sam2 is getting welcome, and in sam, yes, after connection accepted from this, you can see from system 1 good day. So a two-way communication. But if you are planning for a better two-way communication, we should go for multi-threading, where one thread is responsible for sending the data, other thread will be responsible for receiving data. Otherwise, there will be a slight problem. When this line is executed, here it will be blocked. It will be waiting for an input data from other system. Only after that, the remaining lines will be executed. So it is better to go with separate threads. One thread, keep it for sending, and another thread, keep it for receiving. That's all about socket programming using TCP in Python. Thank you for watching this video.